So you're going to be looking at some graphs, and you're going to be asked some questions like, where is f of x increasing, decreasing, where does it have a max, a min, concave up, concave down, points of inflection. And depending on which graph you look at, the information is different. Now I went ahead and just used one where I had written in the past so that I could just explain it to you. And I think that'll be easier to make the video a little bit shorter. So if you need to copy it, go ahead and pause the video so that you can copy it and get the information that you need, and then I'll explain it. And if you need to reword some things, you can. If you're looking at f of x, this right here, given f of x, that means that's the graph I'm looking at. Because what's going to happen is you're going to start with a graph, and it's either going to be f of x or f prime or f double prime. If you're looking at f of x, and I want to know where f of x is increasing, then I'm looking for the positive slope. That makes sense. Anywhere on the graph where there's a positive slope. If I'm looking where f of x is decreasing, I'm looking for a negative slope. If I want to know where f of x has a max, this is like our definition that we've talked about. The slope changes from positive to negative. So you're actually thinking about the slope. But the part that, if you're just looking at the graph, you're thinking about places that are higher than all the other places. It could be a place where the derivative is 0 or undefined. It just depends. F of x has a min, similar to the max. Concave up, you're looking at intervals where the graph has that shape. You just sort of have to figure it out based on the graph. Same thing about this one. Points of inflection are places where concavity changes. Now if you're looking at f prime of x, and if the question is asking me where is f of x increasing, because you're looking at f prime of x, you're not looking at the slope anymore of the graph. You're still looking at where f prime is positive, but positive means that the graph you're looking at is above the x-axis. And where that graph is above the x-axis is where f of x is increasing. And so when you see the words positive, you're thinking about above and below the x-axis. If it says decreasing, f prime's negative, the graph is below the x-axis. Max and min, you're thinking about places where f prime changes from positive to negative. So you're like thinking about places that are above the x-axis and then below. Same thing for min, below the x-axis and then above. Alright, if I want to know about concavity, I want to know where the second derivative is positive or negative. So if I'm looking at the first derivative, then I'm thinking about the slope of that graph. And then points of inflection are still places where concavity changes. A lot of times it's where the max and mins of f prime are. If you're looking at f double prime, you can't do anything about f of x increasing, decreasing, or max and min. You can figure out where f of x is concave up and down based on f double prime being above and below the x-axis, and f double prime changing sign is where the points of inflection are. If it asks you about f prime increasing, that's wanting to know if you're looking at f prime, if that graph is going up, you're looking at a positive slope, and it looks like I cut off the other part. It's supposed to say that f double prime, if you're looking at f double prime, that it would be positive or above the x-axis. So this means I'm looking at f prime, so I'm looking at a positive slope. If I'm looking at f double prime, I'm looking for f double prime to be positive or above the x-axis. I didn't write f prime decreasing, but it's the same concept. It's just negative slope and then negative or below the x-axis. So let's look at some examples. So here's f of x, and let's say we just want to figure out all of those things from the graph. And so we want to start off at where f of x is increasing. Alright, so let's go and label this graph a little bit. Let's say that this is at negative 1. Say this is at 1. 0 would be in the middle of 1 and negative 1. And that's probably all you need to know. Alright, so we know that f of x is increasing where the slope is going up, so it's going up there and it's going up there. So it looks like the f of x is increasing from negative infinity to 1, negative 1, sorry, and then also 1 to infinity. If I want to know where f of x is decreasing, then I would be looking at where the graph is going down, which would be in the middle of there, from negative 1 to 1. That's the only place that the graph is going down. Okay, if it wants to know about where is f of x concave up, then I'm thinking about where the graph has that shape of it going up. Now, this one's kind of strange because of the way the graph is done. I would say that the graph is concave down till maybe there. And then this part right here is not concave anything. And then here, because of the shape, it's at concave down again. So the concave up is nowhere, no interval. Concave down would be negative infinity to 0 and then 1 to infinity. And then between 0 and 1, I think that is just like a straight line, so it's not concave up or down. And because of that, there's no points of inflection. If there were places where the interval here would change, that would be the places of the points of inflection if there was one. So here we have a graph of f prime of x. And we want to kind of know the same things. We want to know where f of x is increasing, where f of x is decreasing. And I think I might need to write this somewhere else. There might not be enough room right there, so I'm going to write it underneath instead. And then there's some other things with max and min, but we'll do that in just a second. So increasing would be where the graph is going up if you're looking at f of x. But here we're looking at f prime of x. So think about that chart, and you go to the place where it says given f prime of x. If I want to know where f of x is increasing, I'm thinking about where f prime is positive. Well, f prime is positive everywhere where this graph is above the x-axis, not below. So all those green places would be increasing. And so that would be from negative infinity to negative 3, and then 1 to 3, and then 3 to infinity. It'd probably be okay to write 1 to infinity. I usually just write it in the intervals according to the zeros. F of x decreasing would be where the graph is below the x-axis, because f prime is supposed to be negative, and the graph is below the x-axis here from negative 3 to 1. So that's negative 3 to 1, because that's the part below the x-axis. Now, if I want to know where f of x has a max or a min, then I'm thinking about f prime changing positive to negative or negative to positive. A max means I change from positive to negative, so I'm going from positive to negative. That means there's a max at x equals negative 3. This is going from negative to positive. So there's a min at x equals 1. And then 3, it's positive and positive on both sides. It's above the x-axis on both sides. So there's not a max or a min at 3. Okay, so then let's talk about concavity of f of x and points of inflection. So let's say that I want to know where f of x is concave up. Okay, think about going to your table. Remembering we're on the f prime of x side, and we're looking at concavity. It tells us to look where the derivative or the slope is positive. Well, the slope would be positive from here to here. And then the slope would be negative everywhere else. It should be negative infinity to negative 2. And then 2 to infinity. And what that means about points of inflection is that there's one at -2 and one at 2 because that's where concavity changes. So this is about f double prime of x. And if you look at your chart, the only thing that I can tell for sure is about the concavity of f of x. So if I want to know where f of x is concave up, I want to think about where this graph has a positive slope. Well, that's where f prime has a positive slope, I'm sorry. So for f of x to be concave up, f double prime has to be positive. And f double prime is positive where that graph is above the x-axis. So f prime would be positive, those two places. So my answer would be -infinity to -2 and then 3 to infinity. If I wanted to know where f of x was concave down, that would be -2 to 1 and then 1 to 3 because that's where the graph is below the x-axis. And then points of inflection of f of x are places where that changes. Since I'm going from -2 to -2 there on the interval, that's one of them. And then 3 to 3 on the interval, that's the other. So x, or the x values of the points of inflection are -2 and 3. Notice there wasn't one at 1 because it's not changing from positive to negative or negative to positive at 1. So here's three graphs. There's f of x, there's f prime of x, and f double prime of x. And I want you to try to figure out these 4 questions for each one, where f of x is increasing, where f of x is concave down, where f of x has min and maxes, and where f of x has points of inflection. Using those 3 graphs, just try the best that you can.